All right, let's get started. 1A. That thing's got a name, whether you remember it or not. Doesn't matter as much as you know how to write it. No, well, yeah, it is. No, that's true. I was talking about the thing you got to apply. It starts with a C. Yeah. Whether you remember the name doesn't matter as much as whether you remember how to make it. Right? How do you make it? You just take this sign and you flip it. Take that sign and you flip it. And you multiply on the top and bottom. And then you just work it out from there. The only thing that changes that highlighted sign. We flipped it. And technically, we just multiplied by 1, right? So you do a little distribution on the top. And you get negative 8i minus 24i squared. Right? Yeah. All over. Got to do the FOIL thing, yeah? Positive 1. These two are going to cancel out, which is super nice. That always happens. And then at the end, you get negative 9 I squared. Something really cool happens to all those I squareds. All those I squareds become negative 1. So you have negative I, negative 8i, minus 24 times negative 1 over 1 minus 9 times negative 1, which is negative 8i plus 24 over 10, which I think is going to be reduced on the multiple choices. So you're going to want to see it as, I guess 2 is the number or is 4 the number? 2 is the number. Negative 4i over 10 plus 12 over 5. What? No. Thank you. No. Over 5. Over 5. Bad reducing on my part. That's as much as can happen, I think. And that's what your answer would look like. It would look just like that. Perhaps it would be actually flipped around if you want to do one more step. It doesn't change the number, but it would probably have the I at the end. So it would actually technically probably look like that. But your FOIL should always cancel the middle term, so you shouldn't ever have to worry about the middle term. The negative cancels with the positive. And you'll always end up with an I squared on the top and the bottom and turn it into negative 1 every time at the end. Like this setup should always look the same right there. That's the whole point of them inventing that thing called the conjugate, was to make it do the same thing every time, which is eliminate the middles and make 2 I squareds happen, which is super nice. All right. There we go. 1A. What are we going to do now? Like 2A? Is that how? Anybody go home and work one and actually get stuck on any? Mm-hmm.
Because the radical equation.
Those made up ones?
Yeah,
that's what she was saying.
We got stuck on.
Which one were you doing? I think I did B with my other class, so I posted that. So I'll just do A the first one. Boop. Let's see. Said it was what? Photomath said 1/9? It's kind of. Oh, Photomath's wrong sometimes?
I don't know. Were we wrong?
All right, let's see. What do you just? Hey, Aldo, it's here. What are you doing? Just go talk out there. No, you don't. You don't have to be here. But. All right, what are we doing? Squaring both sides. Ending up with 2 minus 2x. That's kind of cool. I like that. Equals FOIL 1 plus 2 root 2 minus x plus parentheses 2 minus x. Cool with that? That was a speed foil. If you don't like it, go do foil on the side, but that's not the hard. I mean, that is the hard part. That is hard. But I don't want to spend all of our time just doing foil every problem today. Anything eliminate or cancel? I don't know yet. I got to do some stuff to see. The one, I'm going to subtract the one, yeah? I'm also going to subtract this 2 probably, huh? And maybe add this x. So then we'll go do all that from this side. -1, -2, plus an x. It's going to give me like a -1. No, still equals 2 root 2 minus x. It is cool. You don't have to divide by 2. You don't have to divide by 2. You could actually save yourself a little bit. You could divide by 2. I would square it first. But you could divide by 2 and get the same thing. If you square it first, you don't have fractions yet. No, you don't. Look, now we don't have to square fractions.
If we divide it by 2,
You move the 2 first. You can still get the same answer. 100%. 100% get the same answer.
so you're gonna give them.
Let's. So we should get +1. I actually can't do this in my brain. I need to FOIL this one. Well, it's too many negative signs. Sometimes the negative signs really get confusing. So first, +1. Outside, +x. Inside, +x. Last, plus x squared. Oh, that turned it all positive. That's kind of nice. So x squared plus 2x plus 1 equals. Well, this is that property that we talked about before. AB squared is the same as a squared, b squared. So it's just 4 times 2 minus x. That's the hard property to remember. It says laws of exponents that are always tricky. So now we got x squared plus 2x plus 1 equals 8. Yeah, I think so, right? So x squared minus 2x minus 7 equals 0. Is that a nice, neat factor? 5 and 2? No. 7 and 1? No. No, it's not.
Let's use the quadratic formula.
I guess we're using the quadratic formula then.
Could you also use it slide the bus like that?
I don't. Well, it would just slide 1 over, and that don't help. Yeah, it wouldn't make it. Man, yeah, that is mean of them, huh? You're saying it's supposed to be 1/9? Guess we'll find out. Negative b, so -2 plus or minus the square root of -2 squared minus 4 times 1 times -7 all over 2 times 1. Right, because we got our a, our negative b, and our c that's negative. Okay. So 2 plus 4 plus 28 over 2. Ooh, I'm not getting that 1/9 that Photomath got. Because that 32 ain't going to be a nice square root.
I think that's square root of like 11.
Yeah, re-Photomath that, and I'll see where, and we can go back and check and see if I made a little algebra mistake somewhere in the way. I thought whenever I looked at them off of that worksheet, though, I picked the ones that had good red answers.
Oh, 16 and 2.
So I'm 16 and 2. So that goes 1 plus or minus 4 root 2 over 2. And you're pretty much done there, yeah? Nothing reduces because of that 1. Wait, where did I get a 1 from? That's a 2. Oh, so then something does reduce. 1 plus or minus 2 root 2. I'm a little trepidatious. Did we make a algebra mistake somewhere? I'm talking earlier. It's this thing up here. The black text at the top. Root 2 minus 2x equals 1 plus root. Yeah.
So
I like that problem. That's not impossible.
Oh, that's 260.
Oh, you know what you're gonna do though? You know what you're gonna do on your test when you get to this one, because you said this is the hardest one. This probably is the hardest one, yeah. You're gonna there's gonna be 4 answers, right? Even if they have a square root in them, you know what you're gonna do? You're gonna take that answer, 1 plus 2 root 2, whatever it is, and you're gonna go up here if you don't like it, and if you have the time to do it, and you're just gonna plug it in and see what happens. You're gonna go big old square root 2 minus 2 times 1 plus 2 root 2. That really doesn't get rid of that square root nicely, though. 2 minus 2 minus 2 root 2. Oh, yeah, it does. Because there's 2's cancel right there. And now you've got... Wait, we don't like the square root of that. Oh, but we don't need to know what it is, do we? We just need to know what it equals. We don't have to solve it to know what it equals. Watch this. Big ol' 1 plus square root of 2 minus 1 plus 2 root 2. 1 plus square root of 2 minus 1 minus 2 root 2. 1 plus 1 minus 2 root 2. Oh. No.
Aren't you supposed to add 4x?
Did I miss something? You're looking. You found it earlier?
Then you subtracted 4x instead of adding.
There's our 1/9. Dang it.
It's not 1/9, but it's yeah, it's not the same.
No, yeah. Dude, why did nobody say that a long time ago?
There's a ton of 4s and I'm like, where is
Oh, so we made
but there's a 4x.
If you're watching the video at home, you're probably screaming at me for like... But hey, we still got a good practice with the quadratic formula. Yeah, it'll change it to positive 6x.
Yeah, would it be -7 and 1?
There's my red mistake.
No, 7 and -1.
And now is it nice easy factor?
Yeah.
Oh my goodness. Well, then why couldn't y'all get it at home? X minus 1, X plus 7, and those turn into 6 together? Yeah, that was way easier. So X equals 1 and X equals... Yeah, that was way easier. Hopefully that's what it's like. And then you go plug those in on your test, and you see what... Yeah, that's what I'm saying. No, I didn't either.
We need an answer key because math says it's undefined because it got some crazy fraction from the quadratic formula.
Interesting. Well, it's not undefined. I'm telling you, that's it, because watch this. We're going to go back and check. Root 2. Well, this one's easier. Look, it's a 1. What is that? That's root 2 minus 2, that is root 0. Okay, does that equal the other side? 1 plus root 2 minus 1. 1 plus root 1. What is that? It's 2?
What?
Oh, crap.
That is not right.
So it doesn't work. No, this is right.
Negative 7.
Which one is true?
So that didn't work, right?
No, it didn't.
Let's go check negative 7. Root 2 minus 2 times negative 7. Root 2 plus 14. Root 16. What is that? Okay, let's check the other side. 1 plus root 2 minus negative 7. 1 plus root 9. 1 plus 3. 4. Does work. So photomath is wrong. But also, this is the interesting thing. One of our answers was wrong. And it wasn't the one that I would have guessed just because of the negative sign. Like if I was having to guess and not check them, I would have guessed, oh, negative sign is probably bad because of negative sign. Nope, it was right. So the reason you got to check that one, that's the only type. All year long, there was that one time in the whole year where I was like, hey, you have to check them. That's the type of problem.
So you get one of the roots when you check it, it's wrong.
Remember the word? Give you $100 right now if you say that word.
What?
Have to check. What's that called?
We have to check the zero.
What's that called?
Solutions.
Starts with an E.
We have to check what?
No. This one is called something. These are both
That's like yelling E words.
for $100. These are both possible solutions, right? I would call 7 an actual solution. And 1 is called something. Starts with an E. It's called extraneous. We did do that one time, remember? A long time ago. It's not a real solution. It solves the problem. But it solves the problem only if you attribute a negative sign to the square root. If we would have attributed a negative sign to the square root right here, it would have solved the problem. But we didn't, because that would make it not a function, because then it would have two different answers for the same plugin.
It would be a plus or minus.
It wouldn't be right? If there were two different answers for the same plugin, number being plugged in, that'd mean when you go to graph it, there's one here. That's my number to plug in, right? And there's another one here. Not a function. That's why extraneous solutions exist, because they don't exist on functions. They only exist in some random cases called the square root. All right, let's not waste all our time on that. Let's get some solvable problems. Anybody else get working and stuck as I just did? So there's no shame in getting stuck.
I cannot see a
Well, no, don't look at this. Look at your paper. Love to. Let's see, 21B. Oh, shoot. Yes, this is awesome. Boom. Okay,
I was gonna say the log domain as well.
there are 3 things that make a domain bad. Before we even try to solve this problem, what are those 3 things that make a domain bad?
Zero as the denominator.
Okay,
And negatives under a square root.
number over 0. Red thing. What'd you say, negative?
Yeah, negative number.
Green thing. What about the blue thing?
Log of a zero or log of a negative number.
Right, okay. So which of these are possible?
In this case, it's the zero being on the denominator.
In this case, pretty much only the red thing, right? That's pretty much the only possible thing. So let's see. What would make it bad? Sometimes your gut is to be like, if x is 0, like right here. But is that okay? Yeah, 0 is a number, right? It's okay for x to be 0. And then this would be 0, 0, 1. So then that answer would just be 2 pretty much, right? Which is totally fine. So the gut is like, oh, what if x is 0? But that's not exactly what we're going to do. What are we going to do with this whole bottom thing?
We gotta solve it, right?
We don't. It's not called solving it, because we take it on to the side, and what do we do with it? We set it equal to 0. Not because we're trying to solve for a solution. We're actually trying to solve for the exact thing that's not a solution, right? So if we set that equal to 0, then it's just a nice easy factor. X plus 1. X plus 1. So you get x equals negative 1. Not as a solution, actually. What is this? This is like the opposite of a solution, right? This is not a solution. This is the only thing x can't be. This is like bad, right? So really what we're trying to say is x better not be negative 1. Ever, ever, ever. That would be bad. So now what does that make the domain? Negative infinity all the way up until you get to that only bad number.
And then union 1.
And that's how it would look on the test. But on that question number 2, the same type of question looks like this. And you would just take this spot at negative 1, put a circle, and it would probably look like that. But that's multiple choice. You're not filling it out. I'm just saying that's what that kind of looks like. Some other people might write it as all real numbers except for negative 1. Not on your test, just math note. Yeah, we can look at another one.
Domain of a log. Alright, just review that.
Domain of a log?
Like, just
Okay, if you see a log, so like let's pretend like one of these just had a log. F of x equals, and I'm gonna put the log on the bottom because that'll actually like make it double bad, right? Actually, this is gonna be no watch. Yeah, no look. Here's domain of a log. That's a fun problem right there. So what are the things that can make this bad? A 0 on the bottom would be bad, right? So first things first, let's start with that. Let's start with the 0 on the bottom. So we take the bottom and we set it equal to 0, right? Log x plus 2 equals 0. How do you get rid of a log? Tenant. Yeah. No, you're right. That's what I say too. I say tenant. Raise it to the power of 10, or you're not raising it to the power. Make it the power of a base 10. We'd exponentiate it. So you got x plus 2 equals 10 to the 0 is? No way, Jose. 1. And x equals negative 1. But actually, that's saying x better not be negative 1. So there's one of your restrictions. But we got to be super careful. There's a if we have another restriction, which up here I made blue. See that blue restriction up there? It's if this inside right here is x plus 2 has to be bigger than or equal to or not or equal to. They're strictly bigger than. It can't be 0, right? 0. No, I don't know the log of 0. That's undefined. That's bad. So then x better be bigger than negative 2. Oh, look at that. That cut out our negative 1 for it. Oh, wait. No, it didn't. No, it didn't. So I'm going to draw my little number line for that one. This is a cool little problem I just made up. Draw my little number line. Put a little hole at negative 1. Start at negative 2. And say x better be bigger than negative 2. And skip out on negative 1. There's my domain. Also known as negative 2, comma, negative 1, unite, negative 1, comma, infinity. That was a fun, good. That's a good question for D. I don't think it shows up because I've already given you the examples.
Oh, so any number between negative 2 and negative 1 will work, but we shouldn't use negative 2 or negative 1.
Correct. Or negative 3 for that.
Yeah.
Because that would give you a negative in your log. And negative 1 technically is fine for the log, but it's bad for the fraction. That's kind of fun. Yeah. So negative 1 was bad for the fraction. It was like a red negative, right? That came from the red condition, which was number over 0. Negative 1 whole came from a number over 0. All this restriction came from the log restriction. Two different restrictions. So negative 1's okay for the log. Look at this. Negative 1's totally okay for the log. It just gives you the log of 1. That's fine. Bad for the fraction. Because the log of 1 is 0. All right, what else we got? That's a good question. That's a really good question.
Is there any size on it?
You tell me. Which number is it?
I know it's an example, but I remember when we had that test, you said cross it out. It's not.
That was because it wasn't on test 1.
It's right there. Oh,
Where?
it's like right there.
Boom. Yes, there is. And let's see. Piecewise functions, we did for a little bit. They're literally just like funnel functions, right? They just take a number and funnel it through a condition to see if it makes sense, if it follows the rules. What, you know how to do it? Yeah. But let's do one. It'll be quick. All we're doing is taking the number. We can do B. So look at 5. Which one of these makes sense for 5? Is 5 in between negative 2 and 2? Then I'm crossing the whole thing out. I don't even want to be tempted by it. Is 5 smaller than negative 2? Cross the whole thing out. I don't even want to be tempted by it. Is 5 bigger than? Heck yeah, so you just keep going, then you plug it in. Negative 2, brackets 5, plus 4 equals negative 6. That's literally the answer. Like, you just funnel it through the system, And if it's only giving you one thing to check like that is, then just scratch it out for the rest of the problem because you're never going to check anything else. So like if it's give like
If it's one condition, we use that condition. If it's only
Yeah.
just ignore the.
oh yeah, like as soon as you get a bad condition, just scratch it out so you're not tempted by the stuff to the left of it. Because there'll always be like weird stuff to the left. Don't be tempted by that. Sometimes they even throw an equal sign in there. Sometimes they even like I've seen them like this before, where they throw in like a 2x if x equals 2, and 3x plus 1 if x does not equal 2. So then you really only have two things to worry about: is it 2 or not? That's literally the point 4, 2 comma 4, and then that line. So, just I've seen that before. I just didn't have an example like it, so I figured it's worth saying. All right, what else? Excuse me. Don't forget Dylan 1. Don't forget your Scantron 882E, I guess. All right. What other problems we got going on?
Finding out possible rationales.
Which one?
Anybody?
15 feet.
15B. What are we looking at? Oh man. It's solvable. It just looks like it looks way uglier than it is. Yeah, it's literally just the middle thing doesn't have a common denominator, and that's it. Let's just get the middle thing to have a common denominator and ignore how scary it looks. Because I agree that when you first look at it, you're like, whoa, no thank you. But after looking at it a little bit longer, the only thing I really noticed is that middle thing doesn't have the same common denominator. So the hard part is figuring out what gets it to the common denominator. But it's not that hard. What gets us a common denominator?
Let's see. Would that be m minus 1?
I think m minus 1, yeah. But before we do that, we got to do one other thing I should have said first. No, before we even do that, there's one. Anytime you see
m minus 1 over m minus.
Nope. Even before that, and it's not a hard thing. It's just whenever you see this type of problem, the first thing you need to do is something special. No. It's super easy. It's super important, and it's only for this type of problem. We wouldn't do it if we saw this type of problem.
LCD.
We are going to get the LCD, but that's not the first thing we're going to do. We wouldn't do it for the second type of problem, and we have to do it for the first type of problem because of a third grade rule.
Whatever we do to the one side, we do the other.
No, that's like a sixth grade rule. That'd be algebra 1 in like 6th, 7th grade. This is like a third grade rule. Like actually third grade rule.
Oh, the something can't equal 0.
What can equal 0? Right. Why?
Because it will be undefined.
But why in third grade terminology? Why in third grade words? No. But in third grade words, what is that called? No, they don't know that word. But you're right. That's what it is. No, they don't know. They don't have fractions even. They didn't even have fractions. But they don't have that word. What? It's the thing everybody was in third grade. Everybody's teacher said, this is bad. You can't do this.
Wrong.
You can't do what? There's only one bad thing they ever said, really. Said you're not allowed to do this.
You cannot divide by 0.
Yeah. Right? Right? No, it's true. You heard that, right? Your teacher at some point was like, you can't divide by 0. You can divide by every number. You just can't divide by 0. That's the note we need to make in our brain before even starting this problem. Because we're about to get rid of the denominator. When we get a common denominator, we're multiplying and it's gone. Yay. But before we do that, I'm going to say, right here, m better not be what? So for this problem, off to the side. I just always make it a little note. I don't know the technical correct math way to do it. This is my way. It's actually a restricted domain. That's the way to do it. But note, m better not be 0. Cool. But there's another thing that m better not be. M squared minus m better not be 0. Which means I got to do a little bit of math to sort that out. Factor it out, and you get m minus 1 better not be 0, which means m better not be 0, and m better not be 1. Okay, there's our restricted domain. Ugly as it is, it's those three things. 0, 0, 1. You don't need the second 0, but it's there anyways. Cool. We're not even using that. We're going to go get our answer now. If that comes back to bite us, though, we won't include it in our answer. That's the only thing that that's for. Okay, here we go. So, but actually, that kind of helped me see the common denominator right there when I had to do that. That's kind of nice. So I'm going to leave the first term all by itself. And the second term, I'm going to leave some space to do something funky to. By
m minus 1
over. And then the third term, I'm going to leave alone again. Cool. And then we should be cooking. 1 plus m minus 1 over m squared minus m equals 5 over m squared minus m. Well, now I know what I'm going to do for sure. What are we? Yes.
Yeah, multiply both sides by m squared minus m.
And you know why we're allowed to do that?
Because we totally eliminate all denominators.
And we already took care of the 0 on the bottom. So we're allowed to do that. Because we took care of that 0 on the bottom. We know it in our note. 1 plus m minus 1 equals 5. Oh, look at that.
M equals 5.
Done. Does that contradict our restriction earlier? Nope. So it's a good answer. That's the only thing that green note up at the top was for the end of the problem to check and see if our answer was undefined or impossible. Maybe it would be impossible. If we only got one answer and that answer was up there, impossible problem. Can't do it. If you want to go check it, that's kind of fun. Watch. 1 over 25 minus 5 plus 1 over 5 equals 5 over. So that's 1 over 20 plus 1 over 5. So that's 1 over 20 plus 4 over 5.
4 over 5?
Right?
4 over 5 or 4 over 20?
4 over 20, which is 5 over 20. Gives us, yay, it worked. And we never, in the re-plugin, got a 0 on the bottom, so it was a good plugin. If that number would have been in one of our green numbers and we tried to plug it in, along the path we would have got that 0 back on the bottom and been like, oh crap, what do we do now? So, that does look hard. I agree, whoever asked for it, that one looks hard.
Yeah, it is.
No, it wasn't. There was one hard step, and that's that red step. That red step was the hard step right there. To recognize it and do it was hard. Everything else was workable. But that red step takes a second to be like, oh crap, what is the red thing to multiply to get a common denominator? And then after that, by golly, even if you forget to do this green thing, you can just use all the tops and be done. Once you get the common denominator, you just cross it all out across the bottom, even if you don't combine them again. Okay. What else we got? This is fun. I wish the whole year could just be this.
16. The domain. I just need to write my answer.
16?
Yeah, the last one.
This one looks like soft bracket -4 to 3. This one looks like soft bracket -4 to infinity. And this one looks like soft hard bracket 0 to infinity.
And there's the range, maybe 0.
So those are the domains. And I'll do the ranges, this is, I guess, above in red. Ranges would be soft bracket -2, soft bracket 4. Soft bracket, no. Inclusive bracket at 1 to infinity.
Yeah.
And then infinity to infinity.
Why?
What?
Oh, why would it be
For which one?
Why would the range be negative infinity?
For which one? The sideways parabola?
Oh,
You know when that's going to end? Never. It looks like it's tapering off, but no, it goes forever. We know parabolas and square root functions go forever. They go there slowly. Actually, increasingly slowly as we get farther away, but they're still going forever. It's like the opposite of exponential. The further away you get from 0, the slower it's increasing. Like, you feel safer standing over here than standing right here, right? This guy's going to fall with the skateboard. This guy's kind of going to be chilling on a skateboard. Exponential function's quite the opposite. This guy's kind of happy on a skateboard. But this guy, he's going to slide. He's going down, right? It's kind of interesting. The slope of an exponential function increases. The slope of the square root function decreases over time. All right, what else?
I was actually thinking we could like run through what is it again? Possible
Which one?
rational zeros, like
Oh, just one big possible rational zero thing? Where do you see that?
number
5? Cool. I'm going to do it up here since it's actually pretty. No, this is easier than that. Don't be tripped. This is probably the easiest one on the test, but you have to recognize those 3 words. You have to recognize those 3 words. You don't even solve it.
Oh, you just do the 2 over.
Yeah. Possible is the key word. Not even rational zeros. Possible is just asking for all of the possible ones, not all of the actual ones. So there's going to be some actual, in your set of numbers, there's going to be some bad ones that aren't actually solutions. But that's because this doesn't say list all rational zeros. 5. So TC over LC, right? So which one do you want to do? Let's do the one that has the most things. I think C. C has the most things. So your TC is 6, right? And your LC is 2. Okay. So what are the numbers produced by your TC? Let's write them all out this time and not take any shortcuts because this is your final and it only happens once. Big old square brackets or squiggly brackets. Hang on. It's blue. Okay. 1. I'm gonna write it out because I think that this is how it's gonna show up. Okay, what about on the bottom? I know. I just did bad. And -2 and 2. All right, but that's not how it's going to show up on the thing. You know how it's going to show up? As the individual fractions that this set of series makes. So we got to go one at a time and do the fractions. So you've got 1. Well, let's start with -1, comma. No. Do the one that goes with it. 1. Okay, we just took care of. What's the best way to do this? Top or bottom? I don't even know. I think the best way to do this is to take care of the bottom. So right now we're going to take care of this 1 and this -1 on the bottom, right? Okay, let's get all of those numbers. -1 and 1, comma. -2 and 2, comma. -3 and 3, comma. -6 and 6, comma. That took care of all the ones on the bottom, right? Because technically all of those have a 1 on the bottom. Or a -1. No, it's not. It's actually not. Because you'll be able to recognize it when you're taking your test. Especially if it's multiple choice.
He's just writing them out, and then you'd be like, oh, 1 over 1.
Right. Okay, so now let's do -2 and 2 next. What's 1 over 2? Do we have it yet?
-1/2.
But do we have it yet? Do we have it in our list yet? 1/2. So we got to write it. -1/2, +1/2. What? Okay. Do we have 2 over 2 in our list yet? So we're done with these ones now forever. Do we have 2 over 2 in our list? Yeah, because it's both ones, right? No matter which way it slices. So we're done with the 2's. Do we have 3 over 2? So we need -3 over 2, +3 over 2. We're done with the 3's. Do we have 6 over 2? Either way you slice it, positive or negative, it's going to be 6 over 2 is 3, right? So we took care of those 2, and now we're done with everything. And that's it. That's what it'll look like. I'm pretty sure it'll show that. But it won't show the repeaters. It won't say 6 over 2 and 3. Like, that would be silly. So you do need to recognize where the elimination or equivocation of fraction and a whole number happens. But if you have multiple choice, you should be able to just look at it and see, okay, does this make sense for this fraction or not? And as soon as you see one that doesn't make sense, like they put the bottom number on the top, just scratch it out. Like if they were ever to put a 6 on the bottom there. If we were looking at this problem and I had 6 over 2, and then I look over here and there's a 6 on one of the fraction bottoms, just cross that one out. You know that it can't be possible. If one of the fraction bottoms is bigger than this number, not possible. They're not going to up your thing and unreduce. That'd be silly. All right, what else?
Is there gonna be any graphing where it says just like actually you can't really do that on Sketch.
Is there one where on here where it says graph? Really?
And transformation? Not transformations, but like where you have to give the x intercept, y intercept, aspect.
I thought there was one graphing. Use the following graph to identify the following transformations. Oh, it's missing. Oh no. So perhaps for 23. Is that where that space is from?
I just looked at that. I was like,
I was wondering if maybe that's what this space is from, just in publishing weird. I don't know for sure. Basically, 23 is, do you know the transformations? And can you see if I see just think about a parabola. If we have this parabola, and then I give you transformations of f of x minus 1, could you go back and graph it? Or identify a graph out of 4 multiple choice graphs? The answer to that one would look like this, probably, if that were at 1. When it says use the following graph to identify transformations, that's kind of what it's saying. It's like, hey, I'm going to give you a graph and tell you to transform. Not a hard one. It'll be 1s or 2s or something like that. Can you go and look at another set of 4 graphs and identify it? Because it is multiple choice. I really did think there was one that had you don't have to do them, but it just gives you a function and it says which of these 4 graphs is the most like it. But perhaps that one. I don't know. Maybe it was one of these horizontal asymptote ones or something, where it's like enough information if you just know the horizontal asymptote to distinguish between all of them.
One thing I find hard is to distinguish between the curves. Like, what is it going to look when you
Which curves?
when you use it? Like, you remember when we were using the so like the one that says horizontal asymptote, like the basic function itself.
Mm-hmm.
Like we use it to fix the plotted graph, right?
Uh-huh.
It was one thing that was tricky.
Yeah.
Like
Plotting.
you plotted and then how do you you follow the horizontal
Up or down, closeness or farness from the thing. I know. Yeah, you're saying like you plot it and you plot this line fine and you plot this line fine.
Yeah.
But how do you know if it's going up here or down here or up here or down here technically to curve it out?
Yeah. Hold the curve. Yeah.
Plug in points and see if it's above or below that number. What else we got? Okay, yes. Let's see, but I just saw this, so I just want to point this out. This is kind of a trick question. 32 is kind of tricky.
Solve the equation and find difference of the solution.
So what does solve mean?
Basically find
Solve for x.
Yeah. And how many x's are there usually for a parabola? So then what does that other thing mean?
you subtract.
Yeah, it's kind of weird. I'm just saying. That's why it's there. It's there for a reason. I didn't make up the problem, but I put it there because I want. Read the whole problem. Because it would be real mean of them to do that and then put the solutions on there as one of the answer choices when the question asks you to find the difference of them. but then they just put like the actual solutions. Like let's say this one is 5 and no, this one's probably 6 and 1. Yeah, 6 and -1. No, wait, 3 and 2. C is probably 3 and 2, right?
Yeah.
Positive 3, -2.
Yeah.
If they were to put that as one of your answer choices, but then they also put 1 as an answer choice, like that's mean. You have to read this. So I'm saying read that problem. I'm saying just pay attention. Like this is a weird type of problem to ask. I don't like it, but worth doing. Okay, now what? One. Going all the way up. See? But why? Times by? What's the times by here?
-6 -6y.
You learned something this year.
Yay.
Oh, no, I'm sorry. I meant 2C.
You said 1C.
I know. I meant 2C.
Well, here, now I've already started. I can't not. I'm so sorry. Done? You can take longer. What? Maybe we're going to talk about something that's on there. No, I don't know. No, I don't know. All right, thank you. I'll take it over here. Appreciate it. So what is this? Quickly. 60 minus 30i
Yeah.
plus 30i. Chill.
Isn't that? Oh.
Plus 60i minus
30i
plus not minus 30i squared over. Oh, there's 2 foils. This is terrible. 36 minus 36i squared. Okay, so 60 plus 90i plus 30 times -1 over. Oh, look at that bottom thing about to happen. 36 minus -36. So that's. Oh, I thought I was going to cancel it, didn't it? 30 plus 90i over 72. I'll let you reduce that. I don't want to. Divide by 2, I guess. What do you get if you divide by 2 for all of that? 15 over 36. 36? Right? Oh, so it actually divides by more than 2 then, huh? What is it? 6?
What?
What's 72 divided by 6? 9?
72 divided by 6. Oh, yeah.
Or is it 12?
12 times
12.
6 is
Yeah, it is
12? 12? So divide all these by 6, so we get 5 plus. What's 90 divided by 6? Is that possible?
9 divided by 6.
15.
Is that true?
Oh yeah, 15.
Yeah, that's true. Oh, there's more. No, there's not. That's it. Okay, cool. That's the answer. Sorry. Now, which one did you actually?
3 and 4,
No.
5, 3 and 5.
No. You said B or C?
No, C.
C? All right. So this one is just can you factor, basically. This one is basically can you factor. Can you factor things that aren't super nice and factorable? Does 33 give us a 2 easily? 11 and 3? No.
Nope.
So there's no easy factor? I don't think there's an easy factor here.
No.
All right, here we go.
Which one is this?
This is 2C. -2 plus or minus the square root 4. Oh. Why did I do plus or minus again? Minus 4, 3, -11, all over 6. 2 plus or minus root 4 plus. No?
Yeah, 3 times
2a?
3 times 3.
All over 2a?
No, you're
Negative b over 2a, yeah.
Yeah, it's 6.
Vertex, we should go do that one next.
It's 2A.
Mhm.
Yeah, 2a.
Negative b plus or minus the square root of b squared minus 4ac all over 2a. We just usually a is always 1, so we always just end up doing all over 2. Wait, why did I have 6 there? Why do I have a 2 there?
Yeah, you were just gonna try and recalculate.
Oh, 2a. Plus,
Negative 12.
that's an 11.
121.
All over 6 equals 2 plus or minus root 125 over 6. Root
That's
1.
25 times 5.
It is the cube root of 5, but it's not the square root of anything. Because 144 and 100 and 121.
So wouldn't it be okay like
Oh yeah. Do like 2 plus or minus 5 root 5.
yeah.
And then you don't have to be a hero because it's multiple choice. Literally just put 2 dots. Go 2 plus 5 root 5 over 6. 2 minus 5 root 5 over 6. And which way are we going? Tell me.
It should be greater than 0.
Okay, that's a good thought. You said it's greater than 0. So that means we want whatever's happening to be up here, right?
Oh, so then
Okay, now let's look at our equation and tell us what type of problem that is. What is that shape?
it's a line that's
It's not a line.
Or
It's a, well, I guess it is a line. No, it's not line. Linear function is line. It's a parabola.
so it goes really
so
But what does a parabola look like? Is it happy? And is it happy?
it's a happy one. But
It's happy, so watch this. So where does that, yes. So where does that fall in love with greater than, fall in line with greater than 0?
basically on the right.
And the left.
Oh yeah. Wait, greater than 0.
We're not saying greater than 0.
Only.
We're not saying greater than 0 on the x-axis.
Oh.
We're saying greater than 0 on the y-axis.
Oh.
Because technically, isn't a whole parabola f of x equals x squared, ax squared plus bx plus c?
This thing always throw me off.
No, watch this, watch this. Isn't that true? That's a parabola?
Yeah.
Okay, what is f of x technically supposed to represent? The y value, right? Okay, and what did we say about this thing just a second ago? It was bigger than 0.
Yeah.
So that's technically saying, where is the y bigger than 0? And you don't have to actually like plug in numbers. You can just do that, which is way cooler. If it were flipped around and the sign were the other way, I'd highlight the bottom to check. And it would have actually been in the middle. Oh, what? What'd you say?
Okay, I can get the answer
Uh-huh.
because negative 12 times negative 11 equals to 132, and then 132 plus 4 equals 136 for your square root.
Wait, what? Negative 12 times negative 11 is not 121.
It's 132.
Joseph.
What did I do?
No, you didn't. No, you didn't.
That's 136.
All that does is, no, it didn't screw it all up. All it did is change this. It did not change the answer at all. It did not change. Yeah, it did not change anything. All it did is change that right side. That thing's called something. It's called the discriminant. All it did is change the discriminant. I trust.
11 times 11.
34.
No, because it's multiple choice. You're just going to look at the choices. And it won't be that hard. We're not having, these are just for practice.
So you look at the cube, it's a line around.
Well, it's all, you wouldn't, if it were a line, we'd be done.
Okay, wait. Never mind.
No, it's okay. Like, think about this. If it were a line, we'd be stuck with 2x is bigger than 0. I'm solving for x. Divided by 2, x is bigger than 0. I'm just graphing that. You're done. If it were a line, you're done. A parabola is the only time it gets wonky. We haven't done cubic, but a cubic could be just as wonky where you're having like random chunks. Because a cubic crosses 3 times. So you could have outside, middle, not outside. Depending on whether it bounces or crosses, that kind of thing. So, but we never did cubics. You don't have no cubics. Parabola is the only time that happens.
132 12 times 11 is 132. That was my mistake. I thought
It's okay.
11 times.
I went along with you.
Okay.
I went along with you, so it's my fault too. But that's called the discriminant. Here's a thought: if you don't have a discriminant, if the discriminant, which is that thing that I just messed up on, and then thank you for correcting. If the discriminant's 0, what are you left with?
Discriminant 0.
If your discriminant, that's that thing I just messed up, the red thing that I just changed. If your discriminant is 0, what do you have? This is a fun thought. This is a really good thought because it actually does show up on the test somewhere. And it words itself as a different question, but
Is it H?
if your discriminant,
Negative D over 2A.
this is your discriminant. If your discriminant is 0, what do you have? I shouldn't put over 0. I should put like.
Is it the way, the part where it causes
Wouldn't
the
just be
y-axis?
one solution?
If your discriminant 0, there's only one solution. What is that solution? What the heck? One solution, which is negative b over 2a, which is what? That is h
That we're close to the y-axis or x-axis.
of your vertex, right?
That's what
That is the x coordinate of a vertex. Well, but all you need to know if you want to memorize that is this right here, right? Because perhaps there's a question somewhere. I saw it. I saw it earlier. It's there somewhere, right? Oh, there's the graph. I told you the graph was on there. That's one of the ones that's going to have a 4 multiple choice graphing. We can do that too, but hang on, let me find this vertex one. Is it not on here? Anybody find a vertex one? Holy moly, there's not one? Wait, has anybody actually done the whole review? Why not? That's the best resource you have. Oh, I guess you have the weekend to study for finals, right? Oh, there it is. Number 3. There's your vertex.
relative extrema.
Means min or max. Happens at your vertex. So you're just going to use your formula. This problem is literally just a vertex problem.
But wouldn't you have to? You wouldn't have to put this in the other form, would you?
No, just negative b over 2a. You're done. Negative b over 2a, and you're done. No, you could solve it that way and get the same answer. What was that called? That was called something.
Yes, that.
Completing the square.
Oh,
Remember? Yeah, we didn't even practice it. No. Completing the square would have been like taking the middle term, squaring it, dividing it by 2. So 4 over 2 is 2. Adding it to the outside, trying to get a perfect 2 on the outside. Or I guess it'd be 4.
Yeah, but I don't remember anything about it.
What? Yeah, I know. But that's because the vertex formula of negative b over 2a tells you negative b, so 2 over 2, 1. That's the spot that your vertex is at. 1. And then you plug it back in and you get 1 minus 2 is negative 1, minus 5 is negative 6. 1 negative 6 is your vertex. So I think 1 negative 6 if I did that all right in my brain, but let's check and see. Let's check and see. Negative b over 2a is negative 2 over 2 times 1 is 2 over 2 is 1. That's the x coordinate.
Plug in into the function.
You plug in
Or
1, that's a 1. So then you go 1 squared minus 2 times 1 equals 1 minus 2 minus 5 equals 1 minus 7 equals negative 6. That's your y coordinate. So your relative extrema is the point 1 comma negative 6, and your job is to tell me whether that's a min or a max. Why do you think min?
Because it open parabola.
Because it's a happy parabola or open up parabola. So that's at the bottom. C is the only one where it's going to flip. C is going to have a max because he's sad. His water is all spilling on the floor if it's a cup. If the parabola's a cup, he's sad because he's spilling all his water. Okay, there was another thing we were just talking about before we tangented into that. Oh, is the graphing thing? What number was that graphing one? There it is. Boom. There were 5 things. Remember you said the 5 things? Will you be able to solve it without having to perfect those 5 things? Probably. Is it still good to know those 5 things? I think so. And these ones look like they're easy ones to find them on because there's no like crazy factor. So let's do the easiest one first. I think it's the easiest one. What? I think y-intercept's easiest. I don't know why. I just think it is. Because what if you graph the y-intercept and you can figure it out from that alone? Then just circle the answer. That's why I say easiest one first. So, which one do we want to do? A? A doesn't have any y asymptotes. So that's not, I mean, it is good to do, but A is not going to have any asymptotes. B is going to have 2 asymptotes. C is going to have no asymptotes. Interesting. This makes me wonder which one is most similar. Go home and do them all. Let's do. This is my guess though. Let's do B.
The bottom is bigger. There's a horizontal.
Oh, we'll get there. We're not doing that first. First, we're just going to plug in 0. What is f of 0? 0 over negative 16. So that gives us the point 0, 0, right? Boom, 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 boom. If there's only one graph at that point, you circle it. Dang it. All right. What's the next easiest thing to do? X-intercept, which is setting it equal to 0, but setting the what?
The top.
Setting the top equal to 0. So top equal to 0 is x-intercepts, right? Oh, we've already got it. And that's the only one. No, but the cool thing is that tells us that's the only one. There's no more. So if you see some graphs with more, cross them out. Okay, what else can we solve? Horizontal asymptote. We look at the first two things, which I'm just going to rewrite the first two things over here so we can see it isolated. What are the first two things? X over x squared. There's more stuff, but that's just what we're looking at. So this one says the bottom is bigger. Bottom bigger means y equals 0. So I'm going to draw that line. Boom, 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 boom.
What was it? If the top is bigger, it doesn't have any?
Top is bigger goes like this, to infinity. Okay. I guess the last thing to do is the y asymptotes. They're not called y asymptotes. Thank you. So we go x squared minus 16 equals 0. So x squared equals 16. So x equal plus or minus 4. So that puts one right there and one right there. Well, frick. We got to plot a bunch of points now. It's fine. You can kind of brain rationalize a lot of the points. Like, don't plug in 5. You know what you plug in? 100. Oh, yeah, that's it. Well, no, but I'm saying, like, instead of plugging in this. No. Look, instead of plugging in this 5, this is 5, right? Instead of plugging, here, I should label that as 4 and negative 4. 4, negative 4. That's really the only thing we have, except for the x and y axis. Y, x. No, in your brain, plug in 100, right? Just in your brain, plug in 100. Are you going to get a positive or a negative number?
Wait, which one? Oh.
Plug in 100 in your brain, or 1,000, or 1,000,000. Don't actually plug it in. Just look at it. If you plug in 1,000,000, is it positive or negative? Okay, so then what does that shape look like on the right side?
Like this.
Boom, boom, boom. Because it always looks the same, and we know it's got this asymptote right there on that blue thing, and we know it's got this vertical asymptote right there, and it's got to be positive because you just said positive. So that's kind of what I'm saying is plugging in 1,000,000 is easier than plugging in 5, I think. You see what I'm saying? No? You don't have to plug it in. You plug in 5, you're going to go 5 over 25 minus 16 is this. It's kind of, yeah. You plug in negative 1,000,000, positive or negative number. Negative, right? Because the bottom one,
So it's gonna come in this.
yeah, so it's gonna be flip floppy.
Well, that's way easier than plugging all those points.
Yeah. You just think about like, oh, if I plug in a giant negative number, it's gonna be negative.
What if on a test it has like specific
So
ways
can
that it's
I?
going?
Then you can just plug them into the thing and see if they fit. It's not gonna be 3 functions next to each other. It's just gonna be one function. Grab that point, plug it in, see what happens. Chances are 2 will be close and 2 will be terrible. Chances are, like your x asymptotes will be your y asymptote or something random. And you're like, oh, okay, that's not the right thing. Yeah. Hang on, we got to finish this. Haven't done the middle yet. We've done the outside, but we haven't done the middle. So now we have to plug in that 1 or 2 or whatever you say. I guess I could just plug in 3 because we're really just looking to see if it happens here or there, yeah? So let's plug in 3 and see what happens. 3 over 9 minus 16. Positive or negative? So it's going to be down here. What about negative 3? Negative 3 over 9 minus 16? Positive. So we've got our thing now, huh? That's all we really had to do. Just check a couple points.
I'm still trying to get why did you do this one on the outside? Like, what's the reason?
Well, they always look like that, right? They always look like that. So I had to pick between the green thing or the red thing. That's all I had to pick between. I'm telling you this right now. They always look like those two things, the green or the red. They don't look like this. That's a wave, right? They always look like those two things. That ignore the rest of this.
You mean the curve?
Yeah. You're asking me about this green one right here, right? What were you asking about?
Like, what was the purpose of doing these on the outside if we were just doing
Those are part of the line. The point 5, comma, I don't know, what do you want to say that's 10? Is on this graph.
Oh, so
Let's go look. If I plug in 5, I get 5, 5, 5 over 25 minus 16. What's 25 minus 16? 9. 9? 5 over 9? So that point actually isn't 10, sorry. It's, what did I just say? No. 5 over 9. That's on the graph.
So
The graph is that whole thing. Your domain is, this might help. What's your domain for this graph? No. Negative infinity to negative 4, cut it out. Go to 4, cut it out. Go to infinity. You're right, it's almost what you said, just minus 2 points. Because it never touches those 2 points, ever, ever, ever. Gets super duper close to touching it, but never touches them. Joseph, your brain was thinking about the middle thing only?
yeah,
Your brain was thinking that this was what we just graphed. We didn't. We graphed. We graphed every number in the world except for 2. 4 and negative 4. And where we had 4 and negative 4, we technically drew a red dotted line. And said, better not ever touch that. Because if we do touch that, if we did try to graph the number 4, watch what happens. 0 on the bottom. No can do. Pretty interesting. Pretty interesting stuff. All right. We have a test on Monday. I will be here. What? No, I'm just saying. It's in Dillon 1. It's on Monday at 5 p.m. I'll be here tomorrow at 8 and then from 11 to 12.
what time? 8 a.m.
Yeah, I just usually get here at like 7 or 8. Sometimes earlier. I'll probably be here on Monday. And if not a lot of pre-calculus students show up, I'll probably be here earlier in the day on Monday. But I'm going to record. You're welcome to stay for the next class too. I know everybody's hungry or tired or whatever. You're welcome to stay through the next hour and a half. I know. Me too. You're welcome to stay for the next hour and a half. Recorded this. I already posted the last 2 hours of recordings. If you're studying this weekend and you get stuck on something in the library or something, email me. I'm real quick about responding to problems. Not to like other emails, but to like math problems, I'll respond quickly. Other stuff I put off too much, and I shouldn't. I did. All right, y'all have a good day. Boop. All right. Anybody work on it a little bit over the past 2 days and they got questions yet? You already got one, Maj? No? You raised your hand.
I'm sorry.
Yeah. Number 4? Dope. I'm just going to do them on the review now since we don't have any more days left. So I'm just going to start working them right on here and save it, and I'll post it literally the second class is over. I can upload these notes because they're already uploaded. Find the domain. Which one do you want to do? A couple of them? C? Okay, so domain, well, for normal functions, there's 3 bad domains. For logs, there's only one type of bad thing, but what is the normal bad numbers? Or restrictions? There's 3 types of restrictions on a domain. This is really important to know for not just this problem, but maybe 3 or 4 different types of problems. There's 3 things that can make your domain bad. Where, though? Yes. Yes. A 0 on the bottom is bad. Can that happen here? Nope. We're good. All right. There's another thing that makes it bad. Negative number, square root. Can that happen here? Nope. We're good. There's one last thing. That was the most recent thing we learned. And it's the log of What makes a log bad? These are good. Yeah. Yeah, you're right. A negative number. But we're going to be even more specific and say, what about 0? Is 0 good or bad? It's bad. We don't know the log of 0. So that's it. So when we jump into that one, and we say, which one did you say, D? C? We'll take C, ln of 2x plus 3, and say, what makes this bad? We have to logically think it out. There's no like plug and chug or anything. We just have to logically think it out. What would make this bad? What makes it bad? Here's what makes it bad. If 2x plus 3 is what? Or negative 1, negative 2, negative 3, negative 4, forever, right? So what that's telling our brains right now is that 2x plus 3 has to be bigger than 0. What about this equals thing? I'll draw it in different colors so we can make a decision. Maybe I won't. What about this line right here? Does it get the line? Why doesn't it get the line? Because it can't be equal to 0. We cannot have a 0 there, so it doesn't get the line. It has to, that red double underlined thing has to be bigger than 0 for all 6 of these. ln, log, same thing. All 6 of these, that better be bigger than 0. So then you just solve it normal style, and you get 2x is bigger than 3 with a negative. X is bigger than negative 3 over 2. That's not a domain, though. That's just an inequality. How do you write that? Or recognize it if it's multiple choice test is what you'll actually be doing. No, it'll be on intervals. So it'll say open bracket, negative 3 over 2, close bracket, infinity. And that's saying that x is bigger than 3 over 2, negative 3 over 2, but not quite as big as infinity. But just about every other number in the world. So if you wanted to do number line to help you see that, you could. You could draw your number line. You could make the only point on your number line negative 3 over 2. And you could say, what does it look like for x to be bigger than that number? Well, it looks like a soft bracket or a curved bracket or a non-inclusive bracket. And we're going that way all the way to infinity. So all 3 of those are different ways to write the same thing. But this is the one that's going to be on the test, multiple choice wise. So this is the one that is important to be able to get to no matter which way you get there. What's up? A? Well, yeah. X plus A better be bigger than. Doesn't change anything. Doesn't change anything for any of these. Because technically ln is just the base of E. That base doesn't change the domain. Changes how you get rid of it if it were an equation. How you get rid of that thing if this were an equation would be raise it by the 4. But it doesn't change the domain. So x is bigger than negative 8, which just gives you negative 8. Whoa. Negative 8 to infinity. Yo. E. We're pretty much done from the bat. X is bigger than 0. So 0 to infinity. That's bad. 0 to infinity is E. There's no things to be moved over. Like, it's the same thing, just there was nothing to be moved. Heck, I'm supposed to charge it. All right, what else are we looking at working out? Yeah. 26A? Oh, man. Yeah, we can do 26A. It looks like grouping. Oh, these all look like grouping. Sweet. Okay, good to practice then. I might have enough room up there. You said it was 26, right? Okay. So there's a group. And then the other stuff, you kind of put it in a group like this, but you got to remember it's plus, not times. Like you can't just add a random times in there. It's kind of, I don't like the way grouping is written for that reason. But then you got to decide what's in common for both of them. So what's in common for that first two? Yeah, so we're going to yank out an x squared. So we got x squared outside of x plus 1. Wait. Oh, we can't group this. I'm dumb. Yeah, you should have said that. I didn't realize that from the get-go. Okay, cool. So then if we can't group it, there's something else we have to do. We got to jump to this thing called TC over LC, where we've got negative 3 over 1, because we took this one and that one. So what are your possible rational zeros? They are... Okay, now I definitely don't have enough room for this one. I'm going down. Sorry. Gotta go. Because we're going to do some synthetic division to find the right solution. Doop-a-doop-a-doop. Okay. So we've got x cubed plus x squared minus x minus 3, where the negative 3 is your trailing coefficient and 1 is your leading coefficient. So then we make that little fraction 3 over 1, and that turns into, this is important because this is a different problem. This is like problem 3, I think. Some random problem where it said, hey, what are all the possible rational? So this is, we can do 2 birds with 1 stone here because we can answer the problem. If you see this, what are the possible rational zeros? Let's see. Plus or minus 1, plus or minus 3, plus or minus 1. So if we were going to write it better for like a multiple choice test, it'd actually probably look like this. Negative 1, positive 1, negative 3, positive 3. Do you see any other combos there that can make another number? 1 and 1, positive and negative. 3 and 1, positive and negative. No. If there was a number on the bottom, we could throw in a fraction, but there's not. So, all right, so now we got a long divide. Or, no, synthetic divide. So I guess we just start with 1 or negative 1. I don't know. 1, backwards L. 1, 1, negative 1, negative 3. Drop it down. Multiply to start. You get 1, 2, 2, 1, 1, negative 2. No good. 1's not a solution. Good there? All right, so far? Okay, good. I'm just making sure we're not skipping over the step that mattered. All right, 1's not a solution. Let's try a negative 1. 1, 1, negative 1, negative 3. Drop it down. 1, negative 1, 0, 0, negative 1, 1, 2. Nope, that's not it either. Wait, that's the same thing? That's crazy. Okay, gotta try that 3. Are none of these gonna work? Did you already try them all? Had you done this already? Yeah. Oh, okay, good. I was just saying, if you knew they didn't work. None of them work? Are you serious? Not one of those 3 things works? You're kidding me. I don't trust you. I gotta finish this problem. What's up? Yeah. No, you have to know which numbers that you're allowed to plug in by doing the TC over LC. You don't. If you don't do that, you don't know which numbers you're allowed to plug in. This one just looks super easy because it looks like the 3 and the 1. If it were a 12, you'd have to try 1, 2, 3, 4, 6, and 12. You want to try them all. You just try it till you get one that works. But this one, it just happens to be exactly the same 2 numbers only. You're telling me 3 and negative 3 ain't gonna work, Wash?
It's not working. It's coming like minus 1 plus 12. So 11, like 30, minus 3, 33.
Yeah, 4, 12, 11.
Minus 3 is gonna be
Yeah.
1, minus 5, 5.
Minus 3 would be 1. Minus 3. Minus 2. Minus 6.
5,
Minus 7.
5. Minus
Did I mess up? Positive 6. But it still don't work. 5. Negative 15. What? That might have been a bad typo. Where I gave you one that wasn't factorable. The second one, grouping is faster if it's possible. I think this might have been a typo and was supposed to be a 1. Now that I'm looking at it, which make it way harder because it's with 2 others that look like they're. Well, wait, no, that second. Well, if you pull this one out, are these groupable? No, because that's R minus 6. If you pull a 6 out of 40, or you can't. You pull a 4 out and get 10. 5. 8 out. And get 5 and 2. Oh, yeah. I think it's supposed to be 1. For sure. Because the other 2 do grouping, right? So C would have been you pull out an 8. And you get 5. Oh, 8R squared. And you get 5R minus 1. And then for the other one, if you pull out a negative 5, you get 5R minus 1. That's good.
Yeah, but for B, you don't get
What's up?
for B.
No grouping. I think you can. Divide by 3. If you pull out an n squared here, you'd get 3n minus 2. And if you pull out a negative 3 here, you'd get 3n minus 2. So that makes me think that this is 26 is supposed to be a grouping problem, and I typoed here when I was writing the beginning of B and the end of A that 3 is supposed to be a 1. And that would.
No, what do you say?
I think that there's a typo.
Like 3B.
B doesn't
B
group
is
either.
n squared.
Because you get 3n minus 2. Yeah, and then if you pull out a negative 3, you just get 2n. You don't get 3n.
Oh, no,
Oh, no, you get.
What?
Okay.
Yeah. Okay. Good. You scared me, and I was like, 2 typos. No. This is either supposed to be plus 1 or minus 1, or just
You get plus 2. That's the difference.
not if you pull out a negative.
You get.
Yeah, but minus
Yeah, if
outside.
you put a minus 3, you get the 3n plus 2.
All right.
Minus 6.
We're in the weeds, but let me figure it out.
If you go outside minus 3, inside is going to be plus 3 and minus 2.
N squared,
If you put it minus outside,
3n minus 2.
yeah, check inside.
Minus 3, 3n minus 2. There you go. You're good.
But then if you do minus 3 times minus 2, you get plus 6.
That's plus 6.
Oh, sorry.
It's okay. Oh, did you write it down wrong?
Yes.
Okay. Hey, I just did the same thing with A, so I'm not judging. I agree. It happens. Okay, cool. So ignore A then is the answer to your question, because there's no way to factor that now that I'm thinking. There's no way to factor that if none of the 4 possible rational roots worked. We don't have a way to do it, which is pretty scary. Or perhaps there was supposed to be a 3 here. That would be the only other thing I could think. If it was a typo, either there was supposed to be 3 in the middle, or there was supposed to be a 1 over here. I don't know for sure. So I'm going to scratch it out and save this so nobody else gets in the weeds there later. All right. Let's grab another one. What y'all got? Which one? $18. Oh, nice. All right. Ooh, I don't know what the form of this slope. It says write an equation, and I don't know the form, so I'm going to go ahead and do both forms just so we can see, because I genuinely couldn't tell you. So the first form that you're probably going to use is slope intercept. No. Is point slope. Because you've got a point, which is pretty sweet. And you've got a slope here, which is also pretty sweet. So what's that point slope formula for a line? Anybody remember? Y minus y1 equal m x minus x1. So we're going to go y minus 4 equal -2 x minus 3. Dunsies. This is point slope form if that's what they ask for. But sometimes they don't ask for point slope form. What do they ask for? Slope intercept form, SI, slope intercept form. And if that's the case, then we take it, we distribute -2x plus 6, and then we add that 4 over, and you'd get a different form, which is slope intercept form. Okay. So then the second one, the only thing they've done is rob you of your slope. That's all they've done for B. They've just taken away your slope and said, sucks, you don't have a slope. So your job is to go and find your slope before you start the problem. So you say m equals, and you call this x1, x2. No. x1, y1, and x2, y2. And you just write down y2 minus y1 is x2 minus x1. So you got 1 minus 2 over 4 minus 3 equals negative. Bad. -1 over 1 equals -1. And then it's the exact same problem. You can literally do either of those points and you'll end up with the same thing. Like it's not like you're doing 2 different problems. If you pick either of those 2 points, you'll end up with the same thing given that slope. So that's the only extra step. This is extra step if it looks like part B instead of part A. And then you solve it the exact same way. Plug it in if it asks for point slope form and just leave it like that. If it asks for y-intercept form, you just got to do 2 little things to get y by itself. Yep. 20 a B. Oh, sweet. Okay. So it says this word perpendicular, which is a long time ago. Just what does perpendicular mean? Yeah, but what is it? Yes, it means it passes through the lines, like intersection, like a road intersection. But what does it mean for us in this slope? If this is our slope right there, it's 2 words. If you see perpendicular, it's 2 words. Well, it's actually 1 word, it's twice. Flip, flip. Flip the fraction, flip the sign. So the slope for this thing is m equals positive 2 over 1, which is technically just 2. So perpendicular means flip, flip. Flip the fraction, flip the sign, flip both. Not just one thing, 2 flips. Parallel, while we're here, I know we'll keep going in a second, but parallel means what? Same, right? Same slope, same sign. Same exact thing, don't change anything. So then, if we've got a line that passes through this point, call this our point, and this is our slope, then it becomes just like that last problem we did, where we got to go y minus negative 3 equals 2, x minus 2. Boom, 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 boom. If you want to keep working it out, you could go y plus 3 equals 2x minus 4, y equals 2x minus 7 is your other form of the same thing. But the key there is the difference between parallel and perpendicular. So slope is negative 4 for that one. Slope is 3 for that one. And slope is 2 for the perpendicular one where you have to flip, flip. The equations don't even matter at all. You don't even need to know the rest of the equation. As soon as you see these words, all you're looking for is that highlighted thing. You don't even care about the equation even a little bit. You don't care about anything about that equation. All you care about is the slope from it. If you see those 2 words, parallel or perpendicular, you know, oh, they're going to give me an equation. I don't need it. They're trying to trick me. They could have just given me that slope. It's the same problem as if they just gave you one of those slopes like the last problem we just did a second ago. $30? It's at the bottom. A? All right. Oh, I'm done. Thank you. Oh, man. That's a long one. Okay. A lot of things we could do. Like, there genuinely are a lot of things you could do. But one of them is the most helpful. Like, for instance, there was this rule we learned where if there's something in front, you can bring it to the top and square it, right? Remember that rule of log? But that's kind of terrible because then you got a negative 6 to the top. You know, it's way easier than doing that. What? Divide by what? Because this is technically just a time sign, right? And the opposite of timesing is dividing. What you do to one side, you got to do the other. And look at that. Holy smokes. Log 3 x minus 3 equals 4. That's nice. And how do we get rid of log 3? This is the hard part. You have to remember this. New. It's not hard. It's not a hard process, but it is a new process. How do we get rid of that log 3? Yeah, I know what you're saying it, but there's no good word for it. But yeah, what? Make what the base? Like you put it right there? Is what you're saying? So it's not time. I know what you're saying. It looks like timesing. It's not timesing, but it's making the base the base. Making the base the base. And then it cancels out. Not on the other side, because that's a new problem. But it cancels that out, and we're left with x minus 3 equals 3 to the 4th. Well, 3 to the 4th is the hardest one you'll ever get. Because you can do it twice. What's 3 times 3? 9. 3 to the 4th is what? 81, because 9 times 9 is 81. That's the hardest one you'll ever see, I promise. 3 to the 4th is the highest it'll go. At 4, it'll only go to the 3rd, which is 64, I think. So we got x minus 3 equals 81. So that means x equals 84. Reject any domain not in the domain of a log. Interesting. Is that a possible solution? If we plug it back in, does it give us a negative in the log? If we plug 84 in, is it good? What would be bad? Negative 84, right? Yeah, heck, negative 6 would have been bad. Heck, 0 would have been bad, actually. 0 minus 3 is the negative number. So there were a lot of possible bad things. This wasn't one of them. That's what this note is saying. It's saying, hey, don't forget we have these domain rules. Even though I know you just worked on a different problem, don't forget about the rules of domains too, because perhaps one of these three would end up with an answer. I don't know for sure. I haven't done them all, but maybe one of them ends up with an answer that's not possible, like a negative 4 or something. And then you'd be like, oh, crap. No answer. No solution. Now, what do we got? Don't forget, I'm not done. I'm just, some people walked in late. Monday, 5 o'clock, Dillon 1. That's like that big room. That's a business classroom, and it's on the left in Hinton or Dillon. And a Scantron. One of these Scantrons. I have a few, but still go get your own. And then if you're running late or you need one because you can't find one, I can share some. So no, because then what if someone shows up and I have none left to give them and they had a really bad day, like they got a ticket on the way here and they're 5 minutes late and then I've given all of them away? That would be sad. That's true. I agree. They're there for emergency use, not for preemptive emergency use. How many questions is the review?
A lot. I like 3 for each.
Okay.
Oh, just 33. Right.
That's good though. You get to practice. The thing for the review is if it's really easy, don't do it. If you know how to do it, don't do it. If you don't know how to do it, do all 3 of those. And then you're practicing the stuff you don't know. If you do one and you can do it in like 5 seconds, don't do the rest of them. You know that. But if you do one and you're like, I have no clue how to do this, maybe try all 3 and slowly work through them. It was. Then you email me and I'll work it and be like, oh crap, you're right. And then I'll give you a new one to work and a new one to work and a billion new problems to work. All right, what else looks tough or new or from way too long ago, like test 1-ish? Number 1? Had we done that yet? Have we done a conjugate? Okay, doke. It's so not as hard as it seems like it should be. All you have to do is know this thing right here is what you change. That's what you change, right? So you're going to multiply by -1 minus 3i. And if you do it on the bottom, you're going to do it on the top too. And that's it. You're done. Well, not with the math part, but with the knowing what to do part. The rest of it just follows from doing good little math manipulation. So what happens on the top there? We get boop, 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 boop. Negative 8i. Doom, 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 doom. Negative 24i squared. All over. Ooh, looks like we got to foil the bottom. Unpleasant. Boom, 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 boom. -1 times -1 is 1. Positive 3i. -1 is -3i. -1. -3i is positive 3. Ooh, that's super nice. Look at those two things. And then 3i minus 3i is -9i squared. So then we work that all out. And we end up with negative I, 8I. Ooh, I squared is something I've guessed there was an extra thing you need to know. What I squared is. Indeed. All over 1 minus negative 9. Which is negative 8I plus 24 over, looks like 10. So that breaks down into, holy crap, I don't know. What are we thinking? 12 over 5. Minus, not plus, I almost wrote plus. Plus, minus 4 over 5. I. Math. Yeah. It's multiple choice. So, yeah, that's why I did that. Hopefully they'll help you narrow it down once you get your answer, and you'll be able to see where their bad ones come from. Like as you reduce your answer, you'll see like, oh, they didn't. Like for instance, a really quite possible answer would be those two things, but over 10 still. And it's like, oh, they reduced the top and not the bottom. I see that. That's what they did wrong. I'm not picking that one. But yeah, since it's multiple choice, I'm writing it in the simplest form so it's easy to recognize. So that's that type of problem. The things to know there, I guess, were the conjugate is just changing. Here, look, this is where it happened. It's just changing that sign and recognizing that I squared is negative 1. That's the lessons to learn. The rest of it is just, can you do algebra decently to manipulate stuff, which isn't a given, but is important. All right, scroll through, look for a good one. Number 16. Oh, right, it's already done. You know about domains and ranges? Okay, which one? All of them? B and C? Okay. I'm going to zoom in real quick so we can't see my answers. So I think I did domain in green. Okay, yeah. So domain is the x value, right? And it starts right here, right? So basically all I'm going to do is look at where does it start? X-wise, it starts at 4, right? Soft or hard bracket based on that circle. Soft bracket or uninclusive bracket or I don't even know what else it's called. So then that's my start of my domain. Like I just start there. And then what number is that? 4. So boom. That's literally like how I think of it when I look at it and see it. And there's a comma. How far does it go? When does the x value ever stop? Never. So it's going to go all the way to infinity. Open it up, and that's how you write it right there. So 4, comma infinity. And then for the range, it's almost the same. Where does the y value start at? That's the earliest y value right there. So it starts at 1. Does that line include 1 or not? What? Yeah, it does. A bunch of times, actually. It includes it here, it includes it here, and it includes it at the infinite points in between. So yeah, it absolutely includes 1. And then how high does it go? Infinitely high. Boom. Okay, great. Yes, a good thought. It's like, wait, doesn't it not include 3? Well, what is range? I'm trying to, I could just say yes, it does include it, which it does. But what is range? Range isn't what can y be. That's domain. Domain is what can x be. Domain is what can x be. Range is what does that make y? So then the question is there an x that makes y 3? is there an X number? If the question is, what does that make Y? Is there an X number that makes Y 3? We'll look at like 4.2-ish. Yeah, the point 4.2-ish, comma 3 is on the graph, so 3 is in the range because it's included. Even though it's not included for -4, that's okay. It doesn't have to happen twice. Heck, 4 would be included on the normal line, right in the same spot, even though it doesn't happen over here. So the range is not based on what's missing. It's based on what do these X values that are included tell us about Y. So therefore, yes, 3 is absolutely included because it occurs once. Similarly, if this green line went far enough down, it would include this -2. The range would. But it doesn't because it stops there. But if it went far enough down, it would include that -2 that's over there in a circle, for sure. Not in the domain, though. Not just in the range. And then this one is infinity, infinity for the range. Because this is going to go down forever, and this is going to go up forever. So, negative infinity, positive infinity. And then for the domain, it starts right there. Starts at 0, includes it because 0, 0 is on the graph, and goes on forever that way. So, hard bracket, soft bracket. 0, infinity.
It includes 0 because why?
Honestly, just because of the picture. Genuinely, just because there's no circle there. That's the only reason you can even kind of know that. If it didn't include 0, they would have to show us a circle. Like, there's no lines ever where they're like, haha, gotcha. It was really close, but it didn't include it. Like, that's not a thing they do on tests and quizzes and functions. If it were the function you think it is, which it looks like, it looks really a lot like it's the square root function based on this 4 turning into 2, 1 turning into 1, probably 9 turning into 3 up there. It looks a lot like the square root function. And the square root function has the point 0, 0. So if they were going to be sneaky, they better put a big open circle there for us not to include it. Yeah. We did that so long ago. Domain and range were like week 1 or week 2. So. What else we got? Yeah, absolutely. You got any? Have we done? We have not done absolute value inequality yet. They're kind of sneaky because you have to draw a number line for them. Wait, no, you don't. Yes, you do. I'm silly. What? It is positive. We got to add the negative. Look at all the work we've done. Boop. Boop. All right. You said B for right now? You got any inclination on what to do first to make it a little bit easier for us?
5.
Yeah. Please, please, please do that easy thing first. Don't let them trick you into making the problem harder than it can be by not doing like the normal algebra step first, which is dividing that number. I don't want to do the absolute value thing before I get it as simple as it can be. Okay. Now is the step of learning. Now is the step of this class. Because that divided by 3 technically comes from however long ago algebra was. This step, though, doesn't. This is a new step. How do you get rid of that absolute value sign? What? Changing what sign? We'll say the, but you're right. We're going to change the sign. Which side? The 4/3? So here's what we're going to do. We're going to draw the exact same sign right here. And then you know what we're going to write? The opposite. negative 4 over 3. That's how you get rid of that absolute value thing. So you got negative 4 over 3, 2x plus 1, 4 over 3. And now you know how you solve for x? Same old way you always did, but you have to do it twice. It's kind of fun. It's like a puzzle where you, I don't know, like instead of doing it just to the other side, you do it to all sides. Anything you're going to do to any of those 3 sides, you have to do to all of those 3 sides. So maybe the 1 first. Minus 1, minus 1, minus 1. Oh, you are going to hate this. Anybody else hate fractions? 4/3 minus 1 is 1/3? Yeah? As not fun as that is. And negative 4/3 minus 1 is negative 7/3? Yeah? Sorry for the fraction. I really do apologize. And then divide by 2. Did we divide by a negative number? Nope, that's a positive number. If it was negative, we would have had to do something. But since it's positive, we're good. But it's worth thinking about. So that leaves us with negative 7 over 6, less than or equal to x, less than or equal to 1 over 6. Because remember the little shortcut, you can just drop that straight up. And if you don't like that shortcut, you know what you do? It's a 3 words. What? 3 words if you don't like that little shortcut. Keep, change, flip. Keep the negative 7 over 3. Change the big division to multiplication. Flip the 2 to a 1/2. And you get negative 7 over 6. Keep the 1/3. Change the division to multiplication. Flip it to 1/2 and you get 1 over 6. Or you can recognize the little shortcut and just say if it's on the bottom, it can go to the first bottom too. Same thing if it's on the top, then go to the first top too. It's kind of fun like that. Now I think we're ready to do the graph. And you don't have to be a hero or know exactly where these are. Just write it. Negative 7 over 6, 1 over 6. And what does this say about x? Where is it? Be really, really careful that you read those signs really well. X is bigger than what? So that's like there, right? And x is smaller than what? So that's over there. And does it include it or not? It does, so you get these little square bracket looking things. And I think that's the way the answer looks. But if it's not the way the answer looks, then we have to go back to what we just talked about with domain and range. And how do we write that like the same way we talked about with domain and range? Where's this red line start at? And it goes all the way until you get to, and does it hard bracket or soft bracket? Include or not include? Includes because of that line right there, right? That's why. That's how we knew that. Because that line from the beginning of the problem. And then we unite it with 1/6 to infinite. Zoom out a little bit because I know that's a longer problem. There you go. There's the whole problem. And how you solve. Cool? Yeah, that one would fit. That was one that needed to go down. More problems.
So for 19 we do the same.
Good night. We've done so many. For 19, you do the exact same thing, but there's no absolute value sign. So what do you think you do? Like, let me set it up for A. 1 minus 5A equals 29. How do I get rid of those absolute value signs? Equals minus 29 on the other side, and you're done. So now you got negative 29 equals 1 minus 5A equals 29. And you just do your solve normal style way. And you get 2 answers now, right? Yep. Exact same way. That's fun. Go find more problems. This is the last 25 minutes we have as a class. Sad day. Actually, it's sad. I'll miss you. I'll miss this class. Absolutely. Every class is my best class. That's true. Can't say it on the recording. For prosperity. And I know there's people in that other class that'll watch the whole dang 4 hours. So, hey, whoever I'm talking about knows exactly who they are. What's up? 14D? Oh, sweet. Oh, what? What do you mean, can we do it? It's done. No joke, it's actually done. What do we do with this 14D? Actually, let's just do all 4 of these. This is a fun one to do. And it's so quick. Let's start with A. Log 4 of 4 is? Oh, shoot. Careful. What do you think? Why do you think 1? Why do you think 2?
Oh, sorry.
No, it's okay. I'm listening. Why did you think 1 and why did you think 2? What's the rule? Log B of B equals 1? Sure? Sure it's not 2? Okay, so what's the rule for 2 then? What would be the rule for 2 then? Log B of B squared. There's how we get the 2. There's where the 2 would come in. Okay, so this is a 1 right there, right? So that's a 1. Minus 1, because that's what flips it to the top, right? Or to the bottom. Whoa. What about here? We got to be careful. What is... Well, wait. Yeah. What does ln actually mean? Log E of 1 over E equals minus 1. Log E of E squared equals... Does that help you see it or not? Yeah. If you see ln of E, it goes away. If you see this 4, 4, it goes away. If you see this 8, 8, it doesn't go away because it's not on the top by itself. Literally, if you ever see log 7, 7 to the 7th, third, immediately just go, boop, I'm done. That's my answer. Same with the ln. ln e to the 1 over 172. I don't care what it is. Guess what just happened? Boop, there's my answer. Like, immediately it's done. You just go and you're like, oh, I'm done. ln of E, that's 1. I'm good to go. Oh, it's similar? Yeah, 100%. Because those are quick ones too. If you see that on a test and you know the rules, you can go back and get it real fast. Yes, these are exactly the same thing. Perfect. Thank you. But this one has invisible numbers everywhere but one of these. What's the invisible number right there? Thank you. Please just write it when you see it. I don't care which problem it's on. There's probably more of them throughout this thing. If you go around looking. If you just ever see a log on your test and you're starting a problem, before you even look at the problem, just fill it in so your brain don't forget. Because that makes the first one the easiest one ever. Yeah, because they cancel out. Well, they don't technically cancel out. You're left with the exponent. And there, the exponent technically is 1. So you circle it. That's kind of how that works. Ooh, the next one needs a rule. Yes, that's the rule. Multiplication on the inside turns into addition on the outside. So you end up with log 10, 40 plus log 10x. Pretty much done. There's actually one tiny step you can do. What? No. 20 and 2? No, that wouldn't help. Though I will tell you if you're going to really study for the test. But this is a cool step to do. I just saw it. After I wrote the problem, I was like, oh, wait, there's an extra step we could do. Look at this thing. This thing can break apart even more. log 10, 4 times 10, right? That wasn't a special step. That's just me knowing that 40 is 4 times 10. So now watch this. Log 10 of 4 plus log 10 of 10 plus log 10 of x. Right? So 1 plus log 10 of 4x. I don't know. All these are different ways to write it. I don't know what the right answer is here. It's just all different ways to write the same thing. What do the rules say? Oh, it didn't even say anything. It just find D. Let's do D though. D is the most important one. What are we going to split apart here? Log 10 of 1,000 plus log 10 of x. And that's what's important to recognize right there. Something cool happened on the left. Something really cool happened on the left. Technically, 1,000 can be written as 10 to the third. So that cancels out and just turns into I'm not saying anything, but I'm just saying. If you're studying, study D. Maybe see what happens if you change the zeros. Go to 100, go to 10. Like, I don't know. Try log 10, 10x. And log 10 of an extra couple 0x. See what happens. I'll save that so it's still there. Which one? Too far. Excuse me. Inverse has some steps. It has 4 steps. But even if you forget all, I already did 4 steps, I think, last time. Did we already do it? One of the inverses last time? No? There's 4 steps. But if you forget all the steps and you only remember one step, what's the main step for inverse? I'm just trying to break it down. There are 4 steps, but you really only need to know one of them to be able to possibly get it. Is that what you were about to say too? Switch x and y. Now the other steps are like change f of x to y, change y back to f negative 1 of x. But if you just remember that, then hopefully your brain remembers which one of where in these equations that don't have y actually is. Right? Where's the y value on all those? On the left, right? So let's do the first one. H of x equals root 3 x minus 3. Y equals root 3 x minus 3. Switch x and y. X equals root 3 y minus 3. Now you know what we got to do? Solve for y, just like normal. Get y by itself. Just like when we're doing lines all the time, those linear equations. Get y by itself. So you get plus 3 on both sides. X plus 3 equals root y. How you get rid of that root? You cube both sides. And you get y equals x plus 3 cubed, and you're done. On a test, that will probably look like this. F invert equals x plus 3 cubed. But they mean the same thing. That is the inverse function of those. So you switch x and y and just solve for y, basically, is all you do. The other 2 steps were change f of x to y, switch x and y, solve for y, change y to f inverse prime of x, or inverse of f of x. Find some more problems.
If you look at 32,
Okay.
is the find the different solutions. Like you just have to find zeros.
And then minus them. Difference means subtract, right?
X minus
Yeah, just subtract them.
That's all.
Once you get your solution, subtract. It's just a random question that's possible. I put it there for I didn't write these problems, but like, yeah, if they were to give you one of the multiple choice questions that had both your answers, like one like this one probably is 3 and 2, right? 3 and negative 2? No, negative 3 and 2. This one probably is negative 3 and positive 2. I think. 4, 2, 6, yeah. Then you have to subtract those. Like, it's just a random extra step that doesn't have anything to do with math, but was showed up, so I put it there. So just read. Basically, the trick is read the thing. Don't just answer, but read the thing. I don't like it either, but it's there. It has nothing to do with math. It has everything to do with reading and some random thing they apply. But no, I'm just getting these tests back there. Look for more problems. This is from a different class. We're not leaving 20 minutes early on the last day of class. Oh, you started packing up. All right, what else we got? Which one? 27, the first. Ooh, axis of symmetry. Did we talk about that last class? Okay, we talked about it briefly, so I can do it the shorthand version. Axis of symmetry. It's either f of x equals f of negative x, or f of x equals negative f of x. Wait, I missed one. F of negative x. So either way, all we're going to do when you see that word is plug in negative x. That's all you do. When you see the word axis of symmetry, plug in negative x. Either way. So watch this. If I plug in negative x, I take this away, and I put a negative x there. What did it turn into? Technically, negative 2x minus 10. Right? Okay. Is that exactly the same? No, it's not exactly the same. So then it's not this one, which is y-axis. If they're the same, it's y. So here's a note. Same, which is to say you plug it in, and it's the same y-axis. Every term flips is the easiest way to look at it. Every single term flips sign. If every single term flips sign, then it's origin. And those are the only two possible things. So, did every single term flip signs? No, the 10 is still the same, right? So this one is neither. Or none. Let's do the other. I'm going to do the other two just kind of to have a recurring. So really, you don't even have to do a whole lot. You don't actually have to plug in negative. You can just look at the exponents and think to yourself, is this going to flip or not? Is that cubic function going to flip the sign? Yes, it's flipping it. Is this squared function going to flip the sign? No, it's not. Oh, whoops, I should have done that. Stays the same, right? So basically that one stays the same. Is this negative x going to flip the sign? Yes, it is. And that's not going to flip it. So did it flip every single sign? No, it only flipped 2 of the 4. So it's not origin. And is that the exact same equation as before? Now that I've done my flipping. No, it's not the exact same. I changed 2 things, but I didn't change the other 2. So, none. Ah, here's the first one that's going to hit us. I plug in negative x. Y equals 3. Negative x squared is the same as x squared, right? Same. That means y-axis. And if just for one more example, one small example, it'll be short, of one that has origin, would be if they're all odds. So y equals 4x cubed plus x. They're all going to flip perfectly. That's going to end up being negative 4x cubed minus x.
Can you do that?
Yes. Sorry. Basically, and really, I mean, there's the shortcut way of thinking about this, if you just want to do it without plugging anything in or even thinking about it, here's the shortcut way of doing this. Is look at the exponents including the constant one. Constant has an exponent. What's the constant's exponent? This is the hardest part of this thing. What's the exponent right there behind that 4? It's technically got a little x to the 0 because anything to the 0 is 1. Okay? Because that part matters. You look at the exponents, and if the exponents are all even, it's y-axis. All odd, it's not x-axis. That's not a thing. It's origin. Mixed, none. That's kind of how you can do it without plugging anything in. You look at the exponents. You say, well, look, I know I've muddied the waters by scratching them out, but we've got a 2 and a 0. Why? We've got a 3 and a 2. None. We've got a 1 and a 0. None. We've got a 3 and a 1. Origin. It's kind of the way to think about that really, really quick hand. And if it's multiple choice, then by golly, it's if you can really, really just get that shorthand list down, that's going to serve you well for that one problem on this whole test. It's just one problem. So if you do miss it, it's not a big deal. But if you can remember that shorthand, that'll help you for this specific case. It gets a little different when we throw in like logs and exponents and sines and cosines and that type of thing. But also, this should be I know I've seen a lot of people take pictures, but this should be also online already, as it is currently. Like, well, I don't have internet, but if you go look online and refresh the page, I'm pretty sure all these notes are just happening live. So if they're not, somebody tell me, but I'll check too. Maybe I can log in and check. We have 10 minutes. All right. What? Number 10? Oh, yeah. You know this. In behavior? Oh, it's everything to do with the exponents. And it's actually, I think, only the first exponent. And by first, I don't mean first, because this is sneaky. What do I probably mean by first? Which one should be first? Yeah, but which one should be leading? They tried to trick us by writing it backwards. The biggest one. Look at those big ones at the end. So we're going to look right here, and right here. We're looking at the biggest one. And we're going to say line or not line, parabola or not parabola. Okay, so let's start with the first one and say line or parabola. Oh. What? Why line? Because it's odd. The rule is everything to do with the normal line and the normal parabola. The normal line is this, right? The normal parabola is this. This is the normal parabola, and this is the normal line. That's odd. That's even. Odd, even. That's all we're doing right there. So, line. Okay, what about this one? Line or parabola? Line, because it's odd. Line or parabola? Parabola. Okay, now let's determine happy or sad. Happy or sad? Sad, because the negative sign, right? Happy or sad? Happy. Happy or sad? Okay, now our job is to determine what those two words tell us about the shape. What does a sad line look like? Think about your bank account. Yes, that's a sad line, right? No, actually, think in terms of bank accounts or stocks. If you're trying to think of what sad and happy mean in terms of lines, that's a sad bank account, right? That's not what I want to be happy. What does a happy line look like? Boom, boom. And what does a sad parabola look like? Boom, boom, boom. And that's it. That's what it's going to say. Now, here's the trick of the multiple choice. Is they actually they assign words to this. So the words there's 4 things that it can say. It can say rises, falls, left, and right. So what would we say about this one? We would say it rises on the left and falls on the right. Or we'd say this one falls on the left and rises on the right. We'd say this one falls on the left and falls on the right. That's when I learned this for the first time recently. That's the way that test calls it. But if you can draw the shape, hopefully you can really figure out just by reading the things that they give you, because they literally write it in a long sentence on each of the multiple choice things. And your goal is just to determine, based on that exponent, whether it's a happy, sad, line, or parabola. Any more? No? All right. Where's it at? You need to take a picture of that? You can. I'll save this.